Okay, just finishing up this run of 100 epics on the training data that we had. As you can see, it is continuing to learn, though it's starting to stall out a bit. And you can see, so we're down to 72,105 is the prediction on the test data. So first of all, guessing the number of epics is just not the way to do it. So let me show you the proper way to actually do it is to use early stopping. So how do we use early stopping? Well, the first thing we need to do is actually import it. So it's called a callback. And so if we do from keras.callbacks, we can import something called early stopping. Okay, so this will show up now as a part of our model build, and we're going to add early stopping. And typically, I guess not really the model build, it's actually when you're compiling. So we add early stopping, and here's how you do it. You call it the early stopping monitor, okay? And you're monitoring early stopping. And you're going to set that equal to what we just imported, early stopping. And then you give it what's called the patience. And this is basically, okay, how many times are we willing to see a failure to improve before we stop? Because sometimes like it might stall out a little and then it gets better, right? Now, I would probably go at least 10, but I'll just do 5 for now because I don't want it to take too long to build. And so what this means is the model will continue to build until for 5 iterations in a row it sees no improvement, and then it'll stop and basically give you the score, I think, 5 back. And the way you implement this is you then give it, you put it in your fit, you do it like this. There's something called callbacks, and you set it equal to it's a list of different things, the early stopping monitor, okay? We can also include graphs, which we'll do later, plots of our performance. And this will basically allow us now to sort of set a much higher number of epics. So, you can set it as high as you want. Like, I'll go at least 1,000, go higher to say, okay, if it keeps getting better after 1,000 epics, I'm just going to stop anyways because I want to move on. But you could do like as high as you want because the point is that early stopping is going to have it terminate first. Now, it's good when you're then evaluating to have a validation split, okay? And then I believe it will look at the actual, the validation split. And so for the validation split, it's saying, hey, we're gonna hold aside some of the test data, like 10% of it, and we're gonna look at that as the score each round. I'm sorry, it does the wrong spot, not here. That's at the very end. Okay, I wanted it here in the fitting. Okay, put it before the callbacks. So we have a validation split of 0.1 means when we're fitting an X and Y, we're actually going to fit only on 90% of X and Y. It will still give the score, the mean squared error of that data like you saw before, but it will also show you what it's scoring on the test data. Because if it keeps improving on the training data, like, okay, that could be overfitting. We want it to kind of improve on the validation data. And then the test data is sort of held back at the very end. So it's going to train on this unseen data it hasn't seen before. So it's seeing this, but it's not really using it. We're sort of like using this as a barometer though to like look at the early stopping. And so it's going to be, is this validation data, the 10% improving, not the training data, okay? Because we don't want the model to overfit. And we'll look at later other techniques to prevent overfitting. Okay, so get those changes in, add your early stopping. But if you had a patience of 1, that would be, I wouldn't do 1. I would go like 5 to 10 at least as a low bound. And then after you get that in, we can go ahead and run it. Make sure if I run this, you got to run each time you change code, you've got to run it. Okay, and so what do we change? We bumped up the epic saying, hey, let's just keep going until we don't see an improvement 5 times in a row, and then we will stop. And note that this is still using this 16.8.4 as our hidden layers with 321 parameters to train. Okay, let's give it a whirl and see how we do. And do note that before when I did 100 epochs, like if you look at it, okay, on the training data, 56, 50, it starts to, was kind of still improving, right? And this is what I mean about why you want sort of like 5 in a row, at least, not just like, oh, it got worse, let's stop it right away. Look, it got worse, and then better, worse, better, better. That's what I mean. Okay, so hopefully that makes a little sense. Let's go ahead and run it and see what the net effect is. Now this is going to take some time, but let's look at it. And so you can see here, oh, I think it started on the previous model. Did it? No, I think I recompiled it. No, it just, never mind that. And the loss, by the way, is always going to be different because it's randomizing the weights to begin with. Did it terminate? Yeah, I think it did. It terminated early. I still got a good score. It was as if it kept going with the previous model. Let me just reset this. So I'm going to reset it and then start again. Or maybe it just started that much better. Sometimes it'll start well. And by the way, what I did is I looked at the final score, noted 12 epochs, 74,000. That was comparable to what we got before, but here it only ran 12 epochs. So restarted the code before, restart this code, and let's see how it looks from the top. Yeah, comparable. Maybe it's just doing a better from the start. But what we're looking at really is the validation loss now, and we want this to continue to improve. As long as it's going to continue to improve, the model is going to continue to go. And you can see here, wow, the validation is doing great. It's continuing to drop a lot. So this is looking strong. And we just have to be patient. You got to be patient with early stopping. I'll say this, in the old days of machine learning, people would talk about, you just set these models up and then you go do what you want. The computer's doing the work for you, right? Like you're setting it up. And here we start to see, okay, it's only, it's doing better, but okay, it's starting to get worse. And so, but then again, you get this big jump. And this is what it's doing. It's sort of looking for kind of like new pathways by modifying different weights to try to continue to get closer and closer to that Y. Every time what's happening here, when you see a new score, okay, the weights have been updated to give you that score. And then back propagation, you go back and then you update the weights using gradient descent, okay, to change them, right? And when those weights are changed, and the gradient descent means like you're looking at the air, is it too high, too low, that type of thing. The new weights are put through and you get a new score. And this validation, which is on the 10% of the test data we're holding back, continues to improve. And you can see that the loss continues to improve with it. So this is a neural network in action. We've got early stopping implemented. Like once you have early stopping, you just always use it. Okay, you don't always. I will sometimes just put the epochs first, like to see, make sure the model works. And then after I go through, once I sort of know what I'm doing or like what I see, I'll use the early stopping. And so this is doing great here, right? Okay, I'm just going to let it kind of run out to the video. Let's see what we're at here. We're on, see, it's still 67 epochs, right? So that's only so many. Big data, right? Like you can imagine, you could let these models like go for days, again, LLMs, like we're training 320 models. LLMs have like billions often of parameters to train. That's simply going to take time, right? And did the validations start going up more? Yeah, I think it'll probably, we're down to the 80s. So you sort of look at the general trends. Well, we'll see. And you could estimate the RMSE2 when you're doing which is hard to do. Okay, let me go over the code again while this is finishing. And you're in Colab and you have a lot of lines here. You can pull this up on the side. Okay, so let's look at the deep learning code. All right, so first of all, we import sequential, that's left to right. We import dense, that means everything's connected. And we import early stopping, so we don't have to pick the number of epochs. We initialize our model. That's standard machine learning. We need to specify the number of columns, so we have code for that. And then what makes it a neural network is that we have a hidden layer. You could do it without any hidden layers. It would just be the same as linear regression. And we pick the number of nodes, right? And recall what that means. If you pick 16 nodes, each of your columns, in this case I think it's 9, is going to connect, and it's going to be 9 times 16 for the first layer of parameters. We specify our input shape. This comma means the number of rows that it has, and we give it an activation function. ReLU is working great for us. Now we can add additional hidden layers, as many as we like. And the way we do that is I did say it completed, by the way. I'll just finish this though. When you add this second layer, you're adding 8 new hidden nodes, then 4, then 1. Importantly, what I wanted to underscore is your last output layer has to have 1, because that's what you're trying to predict. Then our model summary nicely will show us the number of parameters. And then you compile it. You could think of these as standard. The optimizers add them in the loss as MSE as standard defaults. Set up your early stopping. You could give it more patience, I think, if you have more time. With early stopping, give it a high number of epochs. If I was doing this on my own, I would at least do 10,000. Give a validation split so that early stopping will look at that. Put your early stopping monitor in the callbacks. And at the very end, you got to see what it does in data it's never seen before. So let's go down to the bottom and see what we got. Thank you for your patience. We got still just 76,000. So it only performed so well on data that it hasn't seen before. Okay, and so that's a lesson here as well, because even though the validation loss continues to improve, hey, that's 10% of the data. Maybe we should up that. And it's also training on less of the data. So we end up getting a comparable score after all. But use early stopping so you don't have to guess the number of epochs.